All right. So we find out that 1.13% from the Z table, right? So that means what? That's the corresponding probability here, right? 1.13%, right? So that's what we call p-value. Everybody, that's what we call p-value. The question is, what if we change the question a little bit, right? Say in the statement or something in the very beginning, we say, we want to test the average cost of college. Is that equal to 5,700 or not? So in other words, we change H1. Instead of grade them, we change that one to be not equal to. So what's happening here, if it's not equal to, that means the p-value will be both sides. Follow me? The p-value will be both sides. Okay, so that means if I have to draw, let me draw that. So that means what? If we change H1 to be not equal to, the p-value will be double. So this region plus that region, both sides. Because remember, if it's not equal to, that means you have to cover both sides, right? So that's the reason you see I put a note here. If it's a two-sided test, everybody, the p-value has to multiply by 2. Follow me? Depending on the p-value calculation, depending on H1, depending on the hypothesis testing, is that one side, is that to the left, to the right, or not equal? That's very, very important. Pay attention to those keywords, okay? All right, so that's what we find out p-value. Now, step number 4 is make a decision. We are going to compare with this p-value we just got, right? 1.13%. With what do we say here, everybody? Alpha. Alpha is always given. Everybody, in the beginning, we say add alpha equal to 5%. What does that mean? That means the probability of making mistakes is 5%. That means we are 95% confident to make that statement. So that's 95 given alpha is 5%. That means the confidence is 1 minus alpha. Remember, we always have that relationship, right? So 1 minus alpha is the confidence, 95%. So now we are trying to compare with this p-value 1.13 with this alpha we got, right? So now alpha is 5%, p-value is 1.13%. We say p-value is smaller, is that right? So p-value is smaller than alpha. What do we say? Okay, this is the tricky part, everybody. In the beginning, it's not that intuitively understandable. So if you find out p-value less than alpha, what do we say? Say reject. Reject what? Reject HO. So you can consider this as a rule. Later on, we are going to explain why is that. Okay, in the beginning, I understand it's not that straightforward, right? Why is that? Okay, we will come back to that later, okay? Right now, we kind of remember if p-value less than alpha, what do we say? Reject. Reject what? Reject HO. Right? So step number 5 is going to make a summary based on your decision from the step number 4. When you say reject HO, right? What does that mean? That's not a human being language. So we want to explain this using a human being language to say what's happening, right? So what's H0 here, everybody? Let's go back, right? They say reject HO. So what is HO here? HO is the average cost of college is equal to 5,700. Remember, that's HO. So we are going to reject that. Reject HO, which is equivalent to accept H1. So why do I care about H1, everybody? H1 here is the claim. Pay attention. You see, that's the claim. That's the claim here. So at the end, when we make a conclusion, we always make a conclusion in terms of a claim. In this case here, is H1. So we say, now we know reject HO. that is equivalent to, say, accept H1. You see that logic here? That's very tricky, right? Everybody follow me? So reject HO is equivalent to accept H1. H1 is right. What does that mean? That means, yes, we have 95% of confidence to say the average cost of a college for all students is greater than 5,700. And we have 95% of confidence to say that. Is that clear? That's our first example here. I did go over a little bit slow. So hopefully you understand those 5 steps. So on the coming exam, there might be one question asking you to write down those 5 steps. So that question will worth more points, right? It's not going to be multiple choice. For that particular question, you do have to write down those 5 steps. Okay, now let's see. So one more time here, right? That's the tricky part, I understand. P-value smaller than alpha, what do you say? Reject. Reject what? Reject HO, right? So now what if you find out if p-value is bigger than alpha, right? So I'm trying to see, trying to help you remember the simple side, right? Remember that simple side, and then the other case, you just put everything to opposite, right? So if p-value, for example, you find out is like 6.13%. So that's bigger than alpha, is right? So if p-value bigger than alpha, then what do we say? Not reject. Not reject what? Not reject HO. Okay, so later on we will have more specific explanation why is that. Okay, I understand it's not that straightforward here, right? Let's see. Another way you can understand this one here is the smaller the p-value, the more confidence to reject HO. I mean, is that, if we are using our logic, you can check this one, right? The smaller the p-value, that means the p-value is very small. It's smaller than alpha. Alpha is usually given, right? Either 5%, 10%, or 1%, right? So if p-value is less than alpha, what do we say? Reject. Reject what? Reject HO. You see that the relationship here? The smaller the p-value, the more confidence to reject HO. All right, let's continue our example number 2. Let's try to go over a few more examples here, then we understand it better and better. Any questions, everybody? Good. Example number 2, claim average cost of a pair of shoes is less than $80. That's the claim they are trying to do, is a pair of shoes. Randomly select 36 pair of shoes, right? So they want to prove, is that a true or is that a false, right? You need to get a sample. Sample of 36 pair of shoes, find out their average cost is $75. Standard deviation is 19.2. Question, is there enough evidence to support the claim at alpha equal to 0.1? Everybody? If we say alpha is 0.1, what's the confidence we are talking about here? Can you type your answer here? If we are given alpha is 0.1, right? So what's the corresponding confidence? Yeah, so that's 90%. Yeah, not a 99, okay? So that's like alpha is equal to 10%. That means confidence 90%, right? So one more time. If we are talking about those 36 pair of shoes themselves, right? We know their average cost, $75. It is less than $80, right? That's 100% true. But how about all the shoes, right? That's our conclusion trying to make from the sample to population for all the shoes we are want to study, right? So step number 1, write down H0, H1. Remember, H0 always equal, right? So this case here, we are trying to say average is equal to 80, or I put it here, everybody, less than 80. Why I put less than 80 here? Because in the statement here, in the claim, right, something they say average cost is less than 80. Now, that's coming from that keywords, right? Less than. So that's H0, H1. Number 2, calculation. Do the calculation, find out what's the test statistics, the z-test. Plug all the numbers. You find out the mu here, we are replacing by what? 80. Because that's under H0, mu is equal to 80. So we replace everything here. We got what? Negative 1.56. Negative 1.56, that's our z, right? That's the test value. So number 3, find out what's the p-value. It's coming from where? Coming from a table. The z-table, the standard, right? The normal table. Negative 1.56, that's somewhere here. Now we have to decide, is that something to the left, something to the right, or both sides? How do we determine that? P-value determined by H1 here. What H1 here tells us? H1 is less than 80. That means what? To the left. So starting from this point to the left, this area is the probability we are looking for. So if you have the z-table, everybody, you can find that directly from the z-table, negative 1.56 corresponding to 5.94%. So that is our p-value, right? So number 4, compare, make a decision. Compare p-value with alpha. Alpha is what? 10%. P-value 5.94%. P-value less than alpha, what do you say? Everybody, can you repeat? You don't have to unmute, right? Try to wake up, right? So if you, everybody, try to say something, wake yourself up, right? So if p-value less than alpha, what do you say? Reject. Reject what? Reject HO, right? So that's number 4, make a decision, reject HO at alpha equal to 10%, right? Number 5 is translate from the stats language into human being language, right? So when we say reject HO, that means what? Accept H1. Why do I care about H1? Because H1 is the claim, remember, right? So H1 is the claim. Reject HO, that's equivalent to accept H1. H1 is right. So yes, at alpha equal to 10% level, in other words, we have 90% of confidence to say the average cost of pair of shoe is less than $80. Are we clear? So that's the conclusion we are getting. So yes, make a decision that the average cost of pair of shoe is less than $80. Any questions? Am I going too fast? I want to double check my speed here. All right. Let's continue. One more example here. So if you go over our first example here, right? First example is to the right. Gradient, right? Gradient. Second example is to the left. Less than. Check it out. That one here. Less than. Now this is example number 3, sorry. This one. Less than. To the left. So remember we mentioned that we are going to cover each case. So the third case will be 2 sides. Not equal to, right? So claim the average wind speed in the city is about 8 miles per hour. So we are trying to show, is that a true or is that a false, right? That statement. So get a sample of 32 days. We find out of those 32 days, the average wind speed is about 8.2 miles per hour. Standard deviation, 0.6 miles per hour, right? Sigma. At alpha equal to 5%, that means our confidence is equal to what? Everybody, can you type an answer here? What's the confidence we are talking about? Can you type your answer to the message window? If alpha is equal to 5%, what's the confidence? Yeah, I see a few, all the people are typing correct answers. That's good. Now, 95%. That's 1 minus 5%, right? Is there any enough evidence to reject this claim, that claim here, right? So what do? Write down H0. H0, remember, always equal. So we are talking about average is equal to 8 miles per hour. So remember, always write down like mu is equal to something, right? So if you have started the homework, right, there are some homework questions they forget, like mu is equal to. They simply write down equal to 8. That's not right, okay? So you do need to have this average, right, equal to 8. H1 here, I put not equal to 8. Why is that? Because in the statement, there's nothing about bigger than or less than. By default, two sides, not equal to. Clear? Number 2, the test statistics plug into the formula, right? So we find out everything here, plug all the numbers, 1.89. Now, this is our test value, right? So we've plugged 1.89. Number 3, find out the p-value, right? So 1.89 is somewhere here. So to help us find out the p-value, remember the p-value is determined by what? Determined by H1. H1 is not equal to. That means what? That means we have to cover both sides. To the left, to the right here, also to the left here. So both sides. So if you got one side here, for example, 2.94%, you can get this directly from the Z table, right? Double that, 5.88, right? So that case here, everybody, is bigger than 5%. So if alpha, previously we mentioned several times, right? If alpha is bigger than, if p-value is less than alpha, what do you say? Reject, right? Reject what? Reject HO, right? Now is the other opposite side, right? So now if the p-value is bigger than alpha, what do you say? Not reject. Not reject what? Not reject HO. Okay, so there's not enough evidence to reject HO. We are not rejecting HO. That means what? We are rejecting H1. That's one statement, right? That's actually not the statement we care about. We still care about HO. Why? Because that's the claim, right? So we are not rejecting HO, everybody. That means what? We accept HO, right? So you can see that logic here. When we say not reject HO, that's the same as saying accept HO. That means HO is right. The average wind speed in that city, it is about 8 miles per hour, given the 32 days of a sample, right? Even though we see a little bit of difference, right? You see that? But it's not that significant. Instead, we say there's not a significant difference to say the average wind speed in that city is different from 8. So it is about 8 miles per hour. So that's the conclusion we are getting here. Follow me, everybody? That's the conclusion. So there is not enough evidence to reject the claim. That means we accept that. Are we good? All right. Let me answer I got some questions. Right. So someone was asking this question here, why do we have to multiply by 2 here, right? So you see that we have the 1.89, right? We draw this bear-shaped curve. We put that 1.89 here. We have to determine, is that one side or is it two side, right? Is that to the left, to the right? Turns out here is what? Is H1 is two side. That means yes, we have to multiply both sides. So for the two side test, we have to multiply that. All right. So that's what we have for this section.